This is a recording for my project demo, CICD, and using EKS Cluster. I'll get started with this demo. So let me also tell what change I'm going to make, and then we can see at the end so how that is reflecting. And so the change I'm making is here. I have two URLs, which is one is a health URL, which is basically for the load balancer to check the health of the instances. And one more URL I have is /test, which returns just hello. This is basically a hello world application in the backend, in the backend. So I'll just change this to hello world so that will reflect at the end. I'll just commit that code later. Okay, and maybe change this also to all good, healthy, and we can see that at the end. Okay, so going back to the architecture diagram, let me explain the architecture diagram. So here, everything is deployed in AWS Cloud, as you see here. And so here we have a user, and whenever a user commits the change, which is code commit here, code commit is, I chose code commit, AWS code commit, and it's similar to GitHub. And so whenever a change is pushed to code commit, and the code pipeline is configured to watch on code commit, and it picks the change and it passes on to the next stage, which is code build here. So the code build relies on a build spec file, and using that file gets executed, and then the end result will get pushed into ECR here. So basically, we're building a Docker image here and storing the Docker image in ECR for later for later the deployment to use this image, or for the pods creation as well. And here I have AWS Systems Manager, so I'm storing my Docker ID and password here, and those are used during the build build phase to fetch any Docker base images. So I'm basically fetching Python base images. There's an alternative way you can also fetch from AWS ECR instead of Docker without storing these credentials here. And yeah, and once the image is built here and pushed to ECR, so this code build is running on a EC2 instance underneath it, and once it's done, so that needs to be deployed here in the worker nodes of EKS. To do that, there is also a AWS service code deploy which doesn't support EKS. So I had to install all the Kubernetes dependencies on code build and trigger a deployment directly from the code build. And and here we have all the IAM service account roles and policies, all that. And here, this is my US East 1 region, and within that, I have a VPC and internet gateway attached to communicate to the internet. And I have two subnets here, public subnet and private subnet. And the public subnet has the load balancer here, route table, NAT gateway, and NAT gateway for the private subnets to use. And the load balancer is the one that directs the traffic from outside the VPC into the private subnet. So the load balancer routes it to the ingress, and the ingress routes it to the service here, and the service will then eventually route it to one of the pod. And all this setup is in EKS cluster. So the master nodes are completely managed by Kubernetes. And here for the worker nodes, I went with Fargate. One more option is EC2. Choose a set of EC2 nodes as EC2 compute instances as your worker nodes. But so Fargate is serverless. I don't have to configure anything or manage any nodes. It's all handled by AWS for me. So this is about the architecture, and I'll just make a code change and let's see through what stages it goes and how is the life cycle. Let me also explain what all files I have. So this is a hello world, as I mentioned. So it just has like hello and then all good and running on port 5000. So going back here, I have all my Kubernetes YAML files here. This is for cluster creation, and this is for deployment. I have only two replicas now. At any point of time, two replicas will be running, and this is for my service, uh, which maps all the pods, and the service name is service CICD, FNCICD, and this is my ingress. So ingress will route it to service. If you see here, the slash test is routing it to service CICD, and slash health is also doing the same, service CICD. And my service is of type node port. And going back, I'll quickly make that change. So I'll do it from the UI this time. So let's change this to hello world. And let's also change this to all good, healthy. So let's commit this. Okay, it's committed. And let's go to code build. Yeah. So the code the code pipeline actually picked up this change and passed it on to code build here. So if you see, the submitter is code pipeline. If a user triggers it, it will be like root or whichever user triggered it. And let me go to code pipeline as well. Okay, so here if you see, these are the two stages. It's code build. I mean, the code commit is the first stage, which is succeeded, and it's pushing on to the next stage, which is code build. And you can see all the build details here. Let's just see all the details here. And while this is executing, let's see what resources we have now. I mean, how old the pods are currently. So we have two pods, and which are like 7 hours, 14 minutes, and 7 hours 38. So I think it succeeded. It also pushed the image somewhere here. Yeah. Yeah. So pushing Docker image here. And let's see that as well. Let's go to ECR. And this is where my image is stored. Yeah. So just like 10 to few seconds back, it's pushed. And we have our image here. And let's see the pods now. I think they should have started by now. Yeah, so it's a rolling deployment. It goes one after the other. So one is in pending, and its creation is in progress. And let me also show the EKS UI. So this is my EKS cluster here. And so if you see the compute, all this nodes, worker nodes are managed by Kubernetes. I have no control how many these get created. Sometimes they can be like four, sometimes seven, whatever, based on the demand or load. So right now, if you see the resources here, and you can see one pod is created, okay, and two pods are old, still old. Let's see through the terminal again. Yeah, it's terminating one, and one is successful, and this one more pending. Let's give it some time, and let's see a few other resources here. And so I have my services also here, So as we saw some time back, this is my service of an CICD, and I also have my ingress here. So the ingress is once you have the ingress resource in your private subnet, and so I have it here, and the load balancer here will like uh, this will get mapped to this. Okay, and if there is only ingress and there's no load balancer, it's of no use. So this load balancer is mapped to this ingress resource, and that we can see here as well. kubectl. So the ingress has the load balancer host address, load balancer address basically. And let me see the pods again. So yeah, I have my two pods running. Just age is 2 minutes and 3 minutes. Let's go see the changes if they're reflected or not. So I have my hello world reflecting here, and I have my all good healthy, which we changed. So my health URL is working fine, and the test URL, which is like hello world, this is also working fine. So all this is automated. Like whenever you commit, uh, all the changes go through it, will go through the entire process. But only these, some of these needs to be created manually, which is like one time job, which is service that needs to be created initially, ingress and load balancer, and obviously the cluster. These are one-time job. Once everything is in place, just these keep changing. Just these change whenever you deploy. Only the pods change. Okay, let's also look at let's also look at the load balancer. I have one load balancer here, and so this have three rules. One is for health, one is for test. Code is supposed to GitHub. I also documented everything, all the steps. Some I didn't document for some like code build, configuring code build, code pipeline, all that. But all the cluster creation, LB, service account, some service account, and OpenID Connect, all that is documented clearly. Thank you.